Alright, so this is another video. This is problem 2.2 out of Griffith Electrodynamics. Before I begin, please like the video and subscribe. And if you'd like to suggest a problem, you can do so on Twitter at PhysicsHelping. So problem 2.2 says, find the electric field, the magnitude and direction, a distance z above the midpoint between two equal and opposite charges, plus minus q, a distance d apart. Same as example 2.1, except the charges are at x equals plus d over 2, and is minus q. Okay? So we'll just use this diagram. So this is now minus q. And let's go ahead and start by drawing the electric field at that point z. Okay, so the first part from over here, the charge on the left, Q, will emit an electric field going this way still. So I'm going to draw that. That doesn't change at all. We assume that that's a positive test charge. So I'm going to call this E1. Okay, or I guess I'll call E positive, whatever works. As for our charge on the right, the negative charge, it's going to attract if we had a test charge there. So it's actually going to be pulling it down and to the right. So this you could think of as being the negative E field. Okay? And by symmetry, hopefully you can see that the y components of the electric field, so E plus in the y hat is equal to negative E minus in the y hat direction, right? So the y component of your electric field cancels out. The only components we have are the x components, and they're both going to be in the positive x direction. So our equation for an E field is, in general, 1 over 4 pi epsilon naught. And then you have whatever charge it is we're interested in, Q. And we're dividing by script r squared. Okay? So in this case, since we're adding two of essentially the exact same thing, I'm going to put a 2 here to count for each charge. And because we only want the x component of these guys, we only want to account for right here. Okay, we only want the x part. Well, we have some theta. Let me move this a little bit. Might be easier actually to do this. To look at it from up here. And I'm going to just draw one E field as such. Oops. And then our theta goes right here. So if we just want the x component, we only want this part. And that is, of course, your sine theta part, because it's opposite. Okay, so with that in mind, we're going to actually then multiply by our sine theta. So we have sine theta, and this is our x hat direction. So now what we can do is rewrite sine theta based on the geometry here. So hopefully you can see sine theta is equal to d over 2 over script r. So that's just going to be equal to d over 2 script r. So I'm going to replace sine theta with d over 2 script r. So that 2 cancels. And you just get 1 over 4 pi epsilon naught times q over script r cubed. Okay. Now script r is this vector, oops, for both charges. So that seems pretty straightforward because this is just a right triangle. So script r is the square root of d over 2 squared plus z squared. And we want that cubed. And this is in the x-hat direction. So then we have, oh, I also forgot there should be a d there. I forgot to plug in the d. 1 over 4 pi epsilon naught times q times d times 1 over script r, but script r we just found, that's d over 2 squared plus z squared. So that's, if we square root that, that's r. We want the cubed root, which is this. Or you could just write this to the 3/2. Same thing. And this is in the x-hat direction. Okay. So this is your electric field. Did they want anything else? No. Perfect. So we found the electric field for that point. Just to re-emphasize, we first took advantage of some symmetry, so we only had to care about the x direction of our electric field. We wrote out a general equation for our electric field in the x direction that adds together both, since it's obvious that the x components add. After that, we replace sine of theta with d over 2 script r, and then we replace script r with the square root of d over 2 squared plus z squared, and then just plugged it all in. And these are, of course, vectors. And then we get our equation for the electric field. So hopefully that makes sense. If it does, please like and subscribe, and I'll post more.